Hello, this is Jim Bradley again, and in my heuristic algorithms course, you will likely want to sort complex data structures. For example, the knapsack assignment uses a dictionary to represent the items, each one of which might potentially be packed into the knapsack. The dictionary keys are the item IDs, and the dictionary values are tuples with two components. The first of those components represents the volume of a particular item, and the second component represents the value of an item. We'll use that dictionary structure as an example in this session. I mentioned the knapsack problem in the introduction. A problem we're going to be doing in class is the cell tower algorithm assignment, which is similar to the knapsack. And the idea there is that you're going to be given as input into your algorithm data on a number of cell towers. And here's an example. And the format of that data is going to be for each element in the dictionary. Notice it says dictionary because it's enclosed in curly braces. The first element before the colon is the identification integer ID for each of the towers. Then for each of the towers, there's some data that's given in a two-tuple. The first of the elements in the tuple at index 0 is going to be the cost of each of those cell towers. And the second element, index 1 of those tuples, is going to be the number of calls that that tower would have the capacity to handle. And of course, your goal here in the algorithm is to pick the best combination of towers that fits within your total budget so that you can handle the greatest number of calls. So again, the format of each one of these dictionary elements is tower ID, the cost of each of the towers, and then the number of calls that each of those towers can handle. Now, one of the ways that you might approach this problem is to sort the data in an order that you think it might be appropriate to consider each one of the towers for inclusion for investment. In other words, you might want to sort the towers so that they're in some sense in the order of most appealing to less appealing. The problem with dictionary here for towers is that you can't sort dictionaries. Dictionaries, for all intents and purposes, if we were to look at the order they're stored in, humans would consider it to be random. It's not really random, but I won't go into the details of how dictionary data is stored here. So we can't deal with random data in an algorithm, so we're going to have to take this data, and one of the ways we can deal with it is to put it into a list. Now, I'm going to hit enter, and so towers will be defined. And let's just check to make sure it's in the computer and it's good. Now, you recall if I wanted to iterate through all the elements in this dictionary, one way I could do it is to use a for loop. And the way I would iterate through towers in a for loop is to iterate through towers.items. And what .items does is it gives, in every iteration, both the key and the value of each one of the dictionary elements. The value here is obviously a two-tuple. And then if I wanted to print out all that information, I could do that, like such. And there are the tower IDs and the two tuples of information for each one of the towers. Now, we can use that idea and recall list comprehension that we used in the CTBA course. And we can use list comprehension to create a list of this dictionary data. I'm going to call that list a separate entity, towers list, And the way that I would do that is to basically unpack the contents of this for loop. What do I want to put into the list? Well, I want to put a tuple of key and values. How do I want to iterate through the dictionary? Well, that's my for statement, so I can copy that, put it down in my list comprehension, and then execute this statement. Let's take a look at towers list and make sure it looks okay, and indeed it does. We have a list of what used to be our dictionary elements in tuple format. The 0th element in each one of those elements is the ID, and then there's a 2-tuple with the tower data. So that's our start. And if we want to sort this, all we need to do is think about some of the videos that have preceded this one in this series. And in particular, one of the ways that we can sort this data is to sort it using lambda functions. So one way you might think would make sense to sort the data would be that it makes sense to consider investing in the less expensive towers first. Well, which data element in each one of these list tuples represents the investment for the tower? Well, it's this one right here. And so if we were to drill down to find that element, for example, in the first or the 0th element in towers list, how would we get to this cost? Well, here's the 0th element of the tuple. This whole 2-tuple is element number 1. So we'll start by typing index 1 in brackets and say, oh, well, okay, within this tuple, which element represents the cost? And it's the first one, or the 0th element. And so that should give us 1.0. And indeed it does. Now, if I want to write a lambda function that hones in on that particular element, I can do it this way by typing lambda to establish my lambda function. Use a dummy variable x for the input into the function. And then what I want to do is for every element that I iterate through this list, I want to do in similar fashion to what we did in the statement above, go to the 2-tuple, which is index 1, then go to the 0th element within that tuple. And I'm going to assign j to that lambda function. And so if we want to just check it out to make sure this works, we can send to it the 0th element of the list, which is this one, and find the cost of that. And so if this lambda function is working, we should get exactly the same thing that we got in this statement right here. The result should be a cost of 1. And indeed it is. Okay, so we have the lambda function j that focuses in on the data that we want to sort this list by. So let's sort it. So towers list dot sort, and I use the argument key because I'm going to use my lambda function to tell sort how to sort that list, and we're just going to sort it by j. And the default, as you may recall, is in ascending order, which makes sense for us because cheaper towers are better. So ignoring other dimensions of the investment problem. So we could sort the list, take a look at it, and you'll see it's not in the same order anymore. It's not sequential numbers 0 through 4, but you'll see that the towers are in a different order. Now, if I wanted to sort not by costs but by number of calls, then what I could do is define a lambda function for that. And I'm going to use the up arrow to get to my previous definition for the lambda function j, because I'm going to just edit that. So I'm going to hit the up arrow until I get that lambda function, and I'm going to create a new lambda function. I'm going to call it k. But instead of focusing in on the 0th element of these tuples, I'm going to focus in on the first element. So this is going to get the number of calls that that cell tower can handle rather than the cost. So I'm going to define that. I'm going to use my up arrow again to retrieve my sort statement. And so now I want to sort by my new lambda function k, not the old one j. And remember, this is going to sort by cost, or excuse me, by number of calls that can be handled. And so in that case, bigger is better, more calls is better. So I actually want to sort this in reverse order. So I'm going to use the reverse argument and set it equal to true. And then take a look at Tower's list. And you'll see that indeed this list is sorted in descending order of the number of calls that each one of those towers can handle, as opposed to the first way we sorted by calls, which was by ascending order of the cost. We could do something that is even a little more complex but possibly useful, which is we could sort by the number of calls divided by the cost. In other words, the calls per dollar, so to speak, that each one of these towers can handle. So in order to do that, I'm going to define a new lambda function. We're going to call it m. We'll use x as the dummy variable again for our input. And then for our output, it's going to be the number of calls, which you recall is index 1, 1 in each one of these elements. So that would be, for this element, the number of calls, which is 1, divided by the cost, which is this element, which is index 1 to get us to the tuple, and then within that, index 0. And so let's set that, and it looks like I forgot the slash to divide by. Let's try that again. So there's our m. I'm going to use the up arrow key to get to my sort, my last sort function, and I'm going to change the lambda function from k to m. Now, let's think about which way we want to sort these. We're dividing the number of calls by the cost. So number of calls is in the numerator, bigger is better there. And cost is in the denominator, and the smaller the cost, the better. And the smaller the cost, if it's in the denominator, is going to make that fraction larger. So we definitely want to sort these in the order of biggest first, and then in descending order. And let's take a look. And you can see that the results make sense, at least if we take a look at the 0th element. For an example, it has a number of calls it can handle equal to 5, and a relatively low cost, not the lowest cost, but a relatively low cost of 1.3. So that roughly is some number greater than 3 calls per dollar, whereas the next item down is 4 calls for $2, let's say, so that multiple is 2. So we're going from something that's greater than 3 in the first case down to something that's 2. Here's another one that's 2, then 1, and then 2/3, something less than 1. So those are three different ways that you could sort the tower data in the cell tower algorithm assignment.